Assalamu alaikum class. How are you all? I hope that you all are fine. Today I am going to present about nuclear magnetic resonance. Nuclear magnetic resonance. What is nuclear magnetic resonance? It is technique used to find number of hydrogen atoms in organic molecule. It can also be used to find ratio of hydrogen in a molecule. Nuclear magnetic resonance deals with the nucleus, deals with the nuclei of the atoms and gives us information of structure of the molecule. So in this case we are dealing with the proton in an organic molecule. So it is named as proton NMR. Proton NMR. There is another type of NMR is carbon 13 NMR, but now we have to discuss about proton NMR. A moving charge or charged particle, creates a field around itself, so the proton is also positive charge, and when proton moves or revolve around its axis, it creates its field. And when this charged particle is placed in external magnetic field, then there will be two possibilities. For example, if it's a charged particle and revolving around axis, creating a field around itself, forming north pole and south pole, and this charged particle act as a magnet, and if this charged particle is placed in external magnetic field, what will happen? If these are molecules in a container, this is a molecule having north and south pole, another is south and north pole, another is north and south pole, and if we apply external field on this system, here is external field, it's north pole, and here is the south pole, and we place that container in between the field. Here there is two possibilities. What possibilities? First is that the molecules align itself according to external field like north pole and south pole. It means that this north pole attracts this south pole and this south pole attracts this north pole. And second possibility is that it opposes the external field like its south pole and its north pole, and here will be the repulsion between the poles. So I can term it as it is the repulsion and here is attraction. Here is attraction. Due to repulsion, the energy of the system becomes high, so it will be higher energy and here will be less in energy. So we can say as that this system will have two types of energy levels if it is a system having randomly atoms and when they are placed in external field they form two type of energy levels. First are those which have low in energy, which are less in energy, and second are those which are higher in energy, and the energy gap between these two energy level is del E. Now if I place external field as, then we can say that this energy level is with the field and this energy level is opposite to the field, as this is with the field and it is opposite to the field. As it is with the field, so its energy level is lower, and it is opposite to the field and its energy level will be higher. I summarize it again. We have a charged particle, and charged particle when moves, it creates magnetic field around itself, and when this charged particle or nuclei is placed in external field, then this charged particle will orientate itself according to external field. Some molecules will orientate itself with the field and some will orientate itself opposite to the field, and this condition makes two type of energy levels. First are those which are less in energy and second are those which are higher in energy, or we can say that these are two energy levels. First level have lower energy and second has a higher energy. Now the nuclear magnetic resonance works on this principle. We use radio waves. These radio waves are used to move the nuclei from lower energy level to higher energy level. When these radio waves are passed on the nuclei which are at lower energy level, then these nuclei will jump toward higher energy level. This amount of energy is absorbed by the nuclei, and this amount of energy will be judged by a detector and gives us information about that molecule. Now a little bit introduction about the instrument. I hope that it is very clear to you. instrument, here is radio wave transmitter or the source of radio waves. Radio waves, and here is the part from where we have to place our sample, and these radio waves are fall on the sample as and here will be the detector which measures the absorbance of radio waves, and after this there will be the recorder, and it will give us spectrum. And here will be one pole of the magnet, north pole, and here will be the south pole of the magnet. What we will do, we use sample of organic compound with solvent and with TMS, tetramethyl silane. I will explain it later. What type of solvent is used? The solvent should be free of a proton. The solvent should be free of a protium, the isotope of a hydrogen. So we use the solvent as D2O, deuterium oxide. Deuterium is the isotope of hydrogen, and it is a inactive nuclear magnetic resonance nuclei, or we can use CCl4. These two solvents are used for the sample preparation. These three things are combined and we put them in this tube. After that, we pass radio waves from the sample, and the molecules in this tube arrange themselves according to these two energy levels. If we apply this external magnetic field, then when the radio waves are passed, the molecules jump from lower energy level to higher energy level, and the absorbance is detected by the detector and gives us signal on the recorder, and recorder gives us a spectrum. How signals are formed? Now we are going to discuss about the formation of graph and the signals, and what types of peak are generated, and how we analyze the structure of the organic molecules. How signals are formed? First I will explain about it. If we have organic molecule like CH3, CH2 and Cl, chloroethane. In this case, it is electronegative atom, so it attracts electronic density toward itself, and this carbon becomes partial positive, this chlorine becomes partial negative, and this becomes partial positive. As chlorine is attracting electron of carbon directly toward itself, so this carbon is more partial positive, and this will be less partial positive. So we can say that these electrons are near to carbon and away from the hydrogen nuclei. Again, we can say that these electrons are near to carbon due to this electronegative atom and away from the hydrogen nuclei. So this hydrogen is less shielded. This hydrogen is less shielded. This hydrogen is less shielded. Or we use the term as de-shielded or de-shielded. De-shielded. And in this case, there is a attraction of electron to a very minimum level. So this hydrogen has electron toward itself, or we can say that electrons are mostly equally distributed between carbon and hydrogen atom. So these hydrogen has an electron around itself. So we can say this hydrogen is shielded. This hydrogen is shielded. Now, if we apply external magnetic field, it's the hydrogen which is de-shielded, It has electronic density toward itself, but it is very in less amount, and this electron has a field around itself as, and it's the external field applied on it. When these electrons are not near to the proton, then the external field will directly influence this nuclei, this proton. So this proton will face the external field with greater amount. We can say that it will face the external field in large amount. So it will be de-shielded and its ppm value should be greater. If it's de-shielded, then it will face magnetic field greatly or more. It will feel more magnetic field because there is an electron which is away from this nuclei, and another nuclei which is shielded. What will happen toward this? It's a hydrogen and electronic density is in greater amount. It means that electrons are near toward the nuclei and it has the field like this. It has a field like this, and here is the external field. In this case, the external field has to apply its effect on the field of electron as well as on the field of proton. So in this case, proton will feel less amount of external field, and it has to face less magnetic field. Now we can say that in this case there will be large value of parts per million. It will show greater field, so its signal should be away or will have greater value, large value of ppm, and in this case its shielded proton, it will face less magnetic field and it will face more magnetic field. Its value will be greater and its value will be smaller. Smaller value of ppm, parts per million. So in this case, when we draw the spectrum, these proton, these hydrogens are always drawn after this proton. Now I am going to draw the graph. As I have told you that in sample preparation we have used TMS. What is the purpose of TMS? First of all, we should discuss about TMS. TMS is tetramethylsilane, CH3, and CH3. It is used as a standard. And its ppm value is 0. So when we use another organic molecule, we always discuss the ppm value of another molecule with reference to TMS. Why its ppm value is 0? In this case, silicon is not too much electronegative and not too much electropositive. So it will not attract the electron and it will not push the electron toward the carbon atom. It shows in between properties of electronegative elements and electropositive elements. So the carbon and hydrogen has actual amount of electron as they have to. So in this case, the value of ppm will be 0. Now graph. Or signal formation within graph. Or spectrum. If we place this molecule, this organic molecule, in a tube containing TMS and a solvent, then we will obtain 3 types of signals. First signal will be at 0 of TMS. Suppose it's the line and here is 0 ppm, here is 1 ppm, here is 2 ppm, and so on. The first peak will be on 0 ppm and it's the peak of TMS, tetramethylsilane. In this case, protons are shielded. These protons are shielded. So we can turn over here as toward this side, we can write as shielding or shielded, shielding, and reverse of it will be de-shielding, or its reverse arrow will show de-shielding. It will be de-shielding. It will be de-shielding. Now from this data we can say as first peak will be on TMS and second signal will be on any value after the TMS will be of these type of proton. If I term them as A and its peak is here, then they will be over here, and these are 3 proton. Their signal will be after the TMS, and next there will be proton B. Suppose their ppm value is here, then their signal will be here, B, and these are 2 proton. Now what is the difference between these 2 proton? As I am showing the similar peaks for these 2 proton, but it is not as there is a effect of neighboring hydrogen on the hydrogen. There will be the effect of a neighboring nuclei on the central nuclei, on the central hydrogen atom. So the peak will be splitted. The peak will be splitted into different parts. It may be singlet. I am removing this side. I termed it as spin, 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 coupling or splitting. Spin, spin, splitting. The splitting is done by the formula n plus 1. N plus 1. This n is neighboring proton, neighboring protons, and this is the proton itself, that is 1. In this case, for a proton, this a proton has another proton or in its neighbor. It is a carbon and it is attached with this adjacent carbon, and here are 2 protons. So we termed as these 2 protons are in neighbor. So for a proton, it will be as 1 plus 2. 1 plus 2. So its peak will be divided into 3 sub-peaks. And in this case, this proton is being affected by these 3 protons. So for this proton, B proton, for B proton, it will be as 1 plus 3. 1 plus 3. Then we can say that it will have the peak splitted into 4 segments. So in this, here the peak for proton A, should be as and the peak for proton B should be as Now, if we receive single peak, then it's a singlet. It's a singlet. If we receive double peak, it's like this, then it's a doublet. It will be as. And if we receive triple peak, it will be triplet. As side peaks will be smaller and middle peak will be larger. If we receive 4 peaks, then it will be quadrat, and it will have as 4 peaks. And we face the 5, 6, 7 and so many peaks, then it will be as a multiplet peak. Now, why this sepulation occur? Why this sepulation occur? Why this sepulation occur? Splitting occur now. Keep in mind that we have same molecule as I wrote earlier as, just try to understand it. It is proton having a field around itself, and we are applying the external magnetic field on it. It is the external magnetic field. Now this proton is facing external field, and this proton also have a field around itself. This proton also have a field around itself, and it also have. So its field will also affect on this proton. Its field will also affect, and its field will also affect. So its effect will cause one peak, and its field will cause another peak, and its field will cause another peak. So these 3 protons are causing 3 peaks, and this field will cause another field. So we termed it as 1 plus 3. So its peak will be quadrat. Its peak will be quadrat. How its peak is quadrat? Because there is a separation due to neighboring proton. Separation occurs due to neighboring proton. So the peak will be divided into other parts. Some more examples regarding graph. First of all, another thing is that is skipping from my mind is ppm value. What is ppm value? Then I will try to explain more examples. ppm value. As we used in sample preparation, main two things and one solvent. First is TMS TMS. Second is sample. And third is solvent. And solvent has almost no effect in readings in the signal in graph. So this TMS will absorb radio waves, and the sample will also absorb radio waves. Both these two components absorb radio waves. Absorbance of TMS is TMS as shown by this sign, and the absorbance of the sample is shown as sample or organic molecule. Now the instrument has a power, and the power of the instrument may be very from 60 megahertz to 300 megahertz, and if the instrument has a higher power, then the graph will be good in result, or it will have best results. If I use the instrument of 60 megahertz, then what will be the ppm value? It has a formula as ppm is equal to absorbance of sample minus absorbance of organic molecule. Sample is organic molecule. Here will be the absorbance of TMS divided by power of the machine or instrument multiplied by 10 to the power 6. This is the formula by which we can find the ppm value for an organic molecule. Suppose absorbance of sample, I am finding the value of ppm for a hypothetical organic molecule. The absorbance of the sample is 2240 hertz, and the absorbance of TMS, in this case the absorbance of the sample is 2240 hertz, and the absorbance of TMS is suppose 2000 hertz, and the power of the machine is, power of instrument or machine is 60 megahertz. Then putting these values in the formula, ppm will be equal to 2240 hertz minus 200 hertz divided by 60 megahertz multiplied by 10 to the power 6. Then by calculating all these values, its value comes as 4 ppm. If we have organic molecule showing absorbance at, or it is absorbing the frequency of 2240 hertz, then the value of ppm will be on 4. Or we can say that the graph will show the signal on 4 ppm. Is it clear to you? Now some examples regarding nuclear magnetic resonance. graph or spectrum for different examples. First is carbon, CH3, 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 and here will be bromine. Second is, I should write it here, CH3, CH2, Br, and third is CH3, CH2, CH2, Br, and fourth is CH3, CH, CH3, and Cl. Next, for this, what will be the graph? Here is the absorbance and here will be the ppm value. ppm value. Increasing sense, and it is the 0 showing PMS. Showing PMS. In this case, we are seeing that this carbon is linked with this carbon and it has no proton. In this carbon, there is also the carbon which is linked by another carbon having no proton. So, these are 9 protons having similar environment. These are 9 protons having similar environment. So, these 9 protons will have singlet peak. Will have singlet peak, but it will be intense as. Why there is no separation? Because all protons have similar environment, so they are electrically neutral. In this case, there are 2 protons. First, these are alpha and these are beta protons. Here is TMS and here will be the absorbance. Now, these protons are de-shielded and these are shielded. So, increasing the value of ppm, and we can also say as de-shielding. De-shielding. So, these are shielded protons. So, its peak will be after the TMS and its peak will consist on 1 proton plus 2 another protons, neighboring proton. According to n plus 1 rule, its peak will be triplet. Its peak will be triplet. So its peak will be over here as for 3 protons. And these are de-shielded and 1 proton is being affected by another 3 proton. So its peak will be quadrate. And after this one as quadrate. It is for 2 proton. In this case, there are 3 types of proton. First, A proton, B proton and C proton. What will be the graph or spectrum? Here is TMS and here will be the intensities. ppm value increasing 0 to above So we can write it as a de-shielding or increase ppm value 1, 2, 3 and so on. So their orientation will be as, first these proton will be mentioned over here, and what type of peak will be 1 plus 2. The peak for a proton will be triplet, 1 plus 2, the peak will be triplet as. And for second proton, first one is itself and there are 5 neighboring proton, 3 and 2, 5 neighboring proton. Then its peak will consist on 6 parts as. So it's for B proton. And for C proton, its peak will consist on first and 2 another proton, so it will be triplet as. In this case, there are 2 types of proton. First are CH3. It has similar environment as its facing. So its graph will have 2 types of proton. Here is TMS and ppm 0, 1, 2, 3, 4 and so on. It is de-shielded and these 2 carbons are a little bit more shielded than this carbon. So the first peak should be of CH3 for 6 protons and it will be duplet. It will be duplet. Why it will be duplet? First carbon first proton and the neighboring 1 proton. Neighboring 1 proton will be duplet. And for this, there will also be multiplet peak. It will show 7 separations. How? First and 6 these are. So there will be 7 separations as. So the covered area of the peak is like this. Thank you. I hope that you have completely understood the lecture, and if you have any question regarding spin flipping, spin coupling, or you want to discuss about equivalence proton, you may ask, you may comment in the section. And please subscribe my channel and share it with the students so many students can take benefit of it. Thank you and Allah Hafiz.